Hi everyone, in this video we'll be looking at tension again and resolving forces such as tension into components. So our example is that a person pulls a suitcase by a rope with a force of 23 newtons at an angle of 60 degrees to the ground. He tries to move the case but finds that the frictional force between the case and the ground is too great, so that the case doesn't move. So the question is, find the components of the force applied by the rope to the case. We need to find the horizontal component of it and the vertical component. So this is the first question we've done where the force is applied at an angle. So our first step is to draw the suitcase. And then to show the rope. And we also need to label the angle. So it says 60 degrees to the ground. So you draw in the horizontal line, and that's going to be 60 degrees. And this rope had a force of 23 newtons. Now the rope is joining the suitcase, but in any case, if you had a tension or a force acting on an object, it has to actually come from the object or goes towards the object. It can't just be sitting in mid-air somewhere out here because that just doesn't work physically. Okay, so we want to work out the vertical component and the horizontal one. So let's make these a different colour. So this will be the vertical and that's the horizontal. So part A. So we need to remember SOHCAHTOA. So everything that you did in year 9 and 10 trig comes into effect here. So we want to find the horizontal one down here. Let's call it H. Actually, let's call it TX because it's on the x-axis. So it's tension the x-axis. So this is our adjacent angle. We've got the adjacent and we've got the hypotenuse. So we want to use cos. So TX is cos 60 degrees, and that's adjacent over hypotenuse. So therefore TX will equal 23 cos 60. And when you got the calculator, you get 11.5 newtons. Remember when you're doing calculations involving trig to check whether your calculator is in degrees or radians. Those of you doing methods are going to start doing radians soon. So that is something that you do need to check when you're interchanging them. Otherwise, if your calculator is in radians and you're using degrees, you're going to get the wrong answer. Okay, so similarly for the vertical, call that TY. This is the opposite side, and we've got a hypotenuse as well, so that means we have to use sine. So opposite over hypotenuse equals sine 60 degrees. So therefore TY equals 23 sine 60 degrees. And in your calculator, once you do that, you're going to get 19.9 newtons. So both of those answers make sense. They're both less than the hypotenuse, which is what you'd expect from a right angle triangle. And this is how you find the components of any type of force. It doesn't just have to be tension, it can be any force at an angle.